Let me quickly show you the network topology before we can start the session. So this is my firewall connected to ISP1 and ISP2. This is port 1. This is port 2. And the firewall is connected to the internal network via a switch. And the clients are connected to the port 3. The test client is having the IP address 1.10.10.10.1. And this is the Fortigate firewall with the firmware version 700. Now we will see the configuration to change the load balancing algorithm. By default, Fortigate uses the round robin algorithm. Now in this tutorial, we'll see how to change that round robin algorithm. And in the SD-WAN configuration, the load balancing algorithm can only be changed for the implicit policy that is already there in the Fortigate firewall. And you will not be able to change the load balancing algorithm for the custom user-defined SD-WAN rule. So let's say you have SD-WAN policy 1, which is user-defined, 2, 3, and by default, there is a implicit SD-WAN rule. And the load balancing algorithm can only be changed for this particular implicit SD-WAN rule. You will not be able to change the load balancing algorithm for the user-defined policy like this one. And it is only for the traffic, which is actually falling back to our implicit SD-WAN rule. So this is the pointer here. And the traffic, if it is matching any of the user defined policy, will not have this SD-WAN load balancing algorithm that we have defined. So it is going to do the routing and the SD-WAN operations based on the SD-WAN policy. And if you want to know the configuration, you can refer my last video on SD-WAN configuration, and you can do the load balancing between ISP1 and ISP2. So this video is totally for the load balancing algorithm configuration for the implicit SD-WAN rule. So let's get back to our Fortigate firewall. So this is our Fortigate firewall. If you click on SD-WAN, you can see my ISP1 and ISP2. These are the members of the SD-WAN zone with the cost 0 for ISP1 and cost 1 for ISP2. And if you come to the SD-WAN rule here, I have a user-defined rule. So which is actually matching all the traffic because I have given the source as all, destination as all, and the protocol as all. And the outgoing interfaces, well, I have use maximize bandwidth, which is going to use the round robin algorithm to load balance the traffic between ISP1 and ISP2, as long as my policy is in enable state. So as long as you have the user-defined policy like this in enabled state, implicit policy will not kick in. And the load balancing algorithm that you will configure, that I'm going to show you in the next step, will not kick in. And your traffic in this scenario, whereas it is matching the user-defined policy, will then be using the criteria mentioned in the user-defined policy, SD-WAN rule. In my case, it is going to be round robin across your network between ISP1 and ISP2. So I will disable this policy so that my traffic will fall back to the implicit rule, which is the last rule in the table. And that's where we will define the load balancing algorithm. And in the last video, I mentioned that the load balancing algorithm can only be configured using the CLI mode. But then I'm correcting myself in this video, and you can configure the load balancing algorithm from the CLI mode as well as from the GUI mode on the firmware version 7.0. And in the older versions of the FortiGate firmware, you may not be able to change the load balancing algorithm. So I'll show you the first step using the CLI mode. Let's switch to the CLI access. So here is my CLI access. And as you can see on my screen, these are the available load balancing modes and algorithm available only for the implicit rule, which is this one. And the first one is the source IP based, which is going to take the source IP information and will only use the same interface. So all the sessions with the same source IP will use the same exit interface. And similar to the source IP based, you have source destination IP based, whereas you will have two criteria for the matching condition, the source and the destination. So the sessions, having the same source and the destination matching this criteria will use the same interface. The firewall will always send the traffic out through the same interface for the traffic initiated from the same source towards the same destination. For example, if you're initiating ICMP and if you have a session on the firewall, so now the firewall knows that the source and the destination are actually using port 1, for example. So the subsequent traffic, TCP, UDP, any sort of applications that you're using on your system will then be using the same interfaces. This is similar to the first option, which is source IP based, whereas you only use source IP information to send the traffic out of the firewall. And next is the source destination IP based. And then comes the weight based, whereas in the interfaces with the higher weights have higher priority and get more traffic. So you can configure the weight for each interface, and then based on the weight, the firewall will always send the traffic through the interfaces with the higher priority. and wait. Next comes the usage based. So all the traffic is sent to the first interface on the list. So you have the interface list. For example, I'll show you the SD-WAN rule here. So this is the interface preference, ISP1 and ISP2. So usage base will send the traffic to the first interface on the list. And you can check the same here as well under the implicit. I mean, we should be checking the implicit rule, not the user-defined rule. So here, session, yeah. Okay, so in our case, the first interface is the ISP1 and the second interface is the ISP2. So usage based means that all the traffic is sent to the first interface on the list. When the bandwidth on the interface exceeds the spillover limit, new traffic is sent to the next interface. So by this, it means under the spillover option, you have the listing as ISP1 first, ISP2 second. So all the traffic will be sent via ISP1, and you can define the ingress spillover threshold and egress spillover threshold. Once the firewall reaches or exceeds that threshold, the rest of the traffic exceeding the threshold will then be pushed out of the firewall using ISP2. And the same goes for the ISP2. You can define the ingress spillover and egress spillover threshold in kbps. When that threshold is reached and the subsequent traffic exceeding threshold, which is a spillover threshold, will then be pushed out of the firewall using the other members. And the last one is the measured volume based. Here, the traffic is load balanced based on the traffic volume. In bytes, more traffic is sent to the interface with higher volume ratio. So regarding the volume based, you have ISP1 and ISP2. You can set the weight here. For example, when I change the weight to 10, you can see the volume changing, the ratio changing. So based on the given ratio, the firewall will choose the interface for the outgoing traffic. So here in our case, when we choose the measured volume based, more traffic is sent to the interface with higher volume ratio, which you can see here in a graphical form. So when I'm setting the weight as 15, it is allocating the percentage to port 2 as 94%, which means 94% of time, the firewall will choose a port 2, and 6% of time, the firewall will choose port 1. So that was all about the load balancing options available only for the implicit policy. So let's try to configure the same. So from the GUI, it is pretty simple. By default, it is going to be source IP based. So first of all, click on SD-WAN. Click on SD-WAN, go to SD-WAN policy, SD-WAN rules, click on implicit rule, click on edit. And by default, it'll be source IP based, which means all the traffic from a source. towards any destination will always choose the same interface. Firewall will actually keep track of the first session. And as soon as the firewall knows about the first session and the destination IP and the routing that it is applying to those sessions, the subsequent sessions will always use the same outgoing interface for different applications and different protocols. So let's try to go back to our CLI and then we'll come back to the GUI method as well. So to configure the load balancing algorithm, you will have to go inside config system SD-WAN. And then you can actually see the configuration here. You can see here I have port 1, I have port 2, and I have all the SLA information, the service information. So to change the load balancing algorithm and the mode, you can use the command set load balance mode, and then you can choose the options available here. For example, source IP based. So now you can see here it is now using the default source IP based. So you can see here it is using source IP based. And the source IP based is using the outgoing interface as the ISP2 14.140.40.108. I have a continuous ping going on from the client, which is going through the firewall. And right now it is using the ISP2. I can show you after clearing the session as well. So it is using ISP2 because my ISP2 is having the IP 14.140.40.108. And this is the IP address of the client 10.10.10.1. You can see here that the firewall is using the ISP2, and I have initiated the connections from my browser, and you can see all the informations about the session, and it is always using 14.140, 4108. Now we'll try to configure the second option. We'll try to configure weight based, or we can try source destination IP based as well. And this is again going to do the same thing. I don't think it is necessary to show this as well because it is similar to the first option. Let's try to use the weight based. I'm checking the GUI to see if it is configured to use the weight based load balancing or not. So yeah, now it is configured to use weight based. And you can configure the weight for each SD-WAN member, ISP1 and ISP2, port 1 and port 2. So we'll try to change the weight for port 1. So this is port 1. So now we can configure the weight for port 1. Let's try to configure it as 2. Let's try to configure weight as 90 for the ISP2. So this is our ISP2. Now let's try to check the same in GUI. So you can see here it is now inside the session tab, whereas you can see the weight as 2 and 90, and it is showing the corresponding volume here. 98% of the time it will use port 2, and 2% of the time it will use port 1. So you can see here, well, let me try to change the weight and try to force the firewall to use port 1 most of the time, which will then be helpful because right now the firewall is using port 2, which is ISP2. Okay, so now we would expect the firewall to put all the traffic or most of the traffic, 98% of the traffic onto port 2, port 1. and 2% of the traffic onto port 2. Let's try to verify the same. So you can see here that the firewall is forcing all the traffic through ISP1, which is our port 1. And out of 100 attempts, you will see 2 of the attempts actually using the port 2, and rest of the attempts will use port 1. You can switch back the configuration to confirm the same. So as you can see here on my screen, that the firewall is using ISP1. Earlier it was using ISP2 because of the weight that we defined. Now we have switched the weight, and the firewall is explicitly, or 98% of the time, is using the port 1 now. Now let's try to configure the last option pending, which is, okay, we have one more option available here, volume based. So we'll try after this. We'll try the usage based. Okay, so for the usage based, you will have to define the spillover threshold. This can be done from the CLI as well. So you can see here spillover threshold for ingress and egress. So the value will be in kbps. Right now we are trying to configure the ingress spillover threshold for the ISP1. So I've configured 100 for ingress and egress. So now I've defined the ingress and egress spillover threshold for the member 2, which is our ISP2 as 80 and 80, which means any of the traffic reaching the firewall and exceeding the 80 kbps threshold will then be pushed out of the firewall using the other member, which is our ISP1. Okay, so the firewall will continue to use the ISP1 until and unless there is any spillover, and the traffic exceeding the spillover threshold will then be pushed out of the firewall using ISP2. And you can see the same thing in your GUI. So you can see the graphical representation of the spillover threshold that we have configured for the ingress and for the egress. So as you can see on my screen, whenever there is any spillover, whenever the firewall is experiencing the traffic more than the spillover threshold, it'll put the traffic onto the ISP2. And to simulate that, I have changed the spillover threshold value. I have kept it as 1 kbps, 1 kbps, which means whenever the traffic exceeds the 1 kbps ingress and egress spillover threshold, the firewall will then use ISP2. And you can clearly see that the firewall is pushing the traffic out through ISP2 whenever there is any spillover. You can see here. So this is using ISP1, this is using ISP2, which confirms that our usage based or spillover based load balancing is working fine. Now comes the last option available, which is volume based. So right now it is set to usage based, which is on the basis of the spillover threshold. Now let's try to configure it to volume based. So now you can use the same weight that we have defined in the last step. I guess weight is cleared off. So let's try to configure the weight. Based on the weight, the firewall will then generate the percentage ratio. Or maybe we can try from the GUI because we already know how to set the weight from the CLI. Let's try to switch back to the GUI. And here inside the volume, you can see that the weight is 1 for the ISP1, and we can set it to let's say 85, and you can see that the percentage ratio, 99% of the time will use port 2, 1% will use port 1. So now let's try to keep this as 90 and this as 10. So 90% of the time it'll use port 1, which is ISP1, and 10% of the time it'll use ISP2. Save. I can show you the configuration in the CLI as well. So you can see here, volume ratio 90, volume ratio 90. This is different from the weight that we have defined in the first step. So for the volume based, you will have to define the volume 90 and 10. The command is set volume ratio 90, set volume ratio 10, and it is a little different on GUI. When you see, it shows as weight. So anyways, so now that it is on the basis of the weight, which is 90% and 10%. So let us check the traffic. So we are expecting 90% of the time that the traffic will use port 1. So it is using port 1 explicitly. This is the HTTP traffic. It is using port 1. Let's try to change the volume to 98% and 99% and 1%. Let's see the effect. So you can see here, most of the time the firewall is using, on 99% of the time, firewall is using port 1. And out of 100 connections, firewall is using a single connection for the ISP2 outgoing interface. And I have a continuous ping going on, which generates a lot of traffic. And most of the time you will see port 1 as the outgoing interface. Hence prove that the percentage that we have defined inside the volume section here is being entertained by the Fortigate Firewall. All right, that's all in this video. If you have any questions, any suggestions, do leave them in the comment section. And at last, please do subscribe to my channel and hit the like button if you really enjoyed this video. See you in the next video. Bye.